Here is problem 4. In the figure shown, US and UT are line segments with each of length 2, and the measure of angle TUS is 60 degrees. Arcs TR and SR are each 1/6 of a circle with a radius of 2. What is the area of the region shown? As you can see, here we have a very irregular region. So whenever we're trying to find the area of an irregular region, we're going to try to break it up into regions that are regular, that we can easily find the areas of, and make it into basic shapes such as rectangles, triangles, or circles. Let's reread the problem and see what we know already. US and UT each are 2. And the angle measure of TUS is 60 degrees. So this is 60 degrees. TR and SR, so both of these two arcs are 1/6 of a circle with a radius of 2. So now if we just moved both arcs, now you will notice that all we have to do is fill in these two sectors, these two portions of the same circle. Now here I won't be able to go all the way, but we know that they're both the same. And we know that if they're 1/6 of a circle with a radius of 2, then this segment here must be 2 as well. So this is 2 and 2. Let's think about it. We know that this is 1/6 of a whole circle. So in order to find the area of this part, we would need to take 1/6 of the area of the whole circle. The whole circle has a radius of 2, and we have to multiply that to pi. So then we have 2/3 pi. Then, because there are 2 of them, we can do 2/3 pi times 2, giving us 4/3 pi. So that is the region of the blue here. Now, what do we do? Well, we also need to find the area of the whole equilateral triangle. Because we know that these two sectors are congruent and they're completely the same, then it means that this will have an angle measure of x, and this will also be an angle measure of x. That makes this entire triangle a isosceles triangle. And because one of the angles is already 60, we know that x and x are both 60 as well. So they're all 60 degrees, meaning that this is actually an equilateral triangle. So this bottom side here would be 2 plus 2, or 4. Now let's think about how we can find the area of this equilateral triangle. Well, we need to know the base and the height. We already know the base, so what is the height? Well, we can use the Pythagorean theorem. So if we just drew the height and made it perpendicular to the base, and we knew that the hypotenuse was 4 and the base was 2, then 2 squared plus h squared for height would be equal to 4 squared. So h squared would be equal to 16 minus 4, or 12. Ultimately, h would equal 2 square root of 3. So this will be 2 square root of 3. Now we can use the height to find the area of the total equilateral triangle. So we will have 4 times 1/2 times 2 square root of 3, which is equal to square root of 3. Now we can subtract the 4/3 pi from the 4 square root of 3. So our final answer would be 4 square root of 3 minus 4/3 pi. And this is our final answer.